I didn't check something off of my list. I didn't start recording. So all those great little things are now going to be, that stinks. Dang it. All right, everybody ready to go back to the start? We're going to do it all over again. All right, I apologize. If anyone has any of those questions about the previous things, please direct message me. I'm happy to go through it. But we do have the code here on the recording. So don't forget that top portion is what we were doing. Dang it, dang it, dang it. It's been a while since I did that. All right. So we are looping through here. We're printing out those dog names. We're seeing it. It's Toby as it's looping through. We are doing great. We're doing loops. We're doing conditionals inside of them. We are on a roll. Let me take out that console log right there. So any questions about what we just did for this example?
Yeah, the empty quotes on the last line, the console.log who let Toby out after the semicolon.
Yeah.
That was just, sorry, that was just
okay. I just making sure.
Yeah. Thank you.
I was the same way.
Wasn't calling you out.
You guys don't know about the semicolon trick? No,
What chapter was that in?
I'm like, it ran, so.
I'm sorry. No, that's just absolutely a typo. Yeah, ignore that.
Okay.
Or is it? Maybe it's not. I'm just kidding. Yes, question. Heard a question.
Okay. I keep forgetting when to use the curly brackets as opposed to the regular brackets.
So curly brackets, we always use with for loops. We use them with if statements. We're going to use them for something else. Square brackets are for arrays. So look at this. This is an array up here. And we're calling to an array down here. They both use square brackets.
Okay.
Curly brackets are for something that's doing something, doing an action. For loops are iterating. If statements are checking conditionals. They need a curly bracket. Arrays are containers. Think of shipping containers. Do they have curly brackets on the outside? No, they have square brackets. Shipping containers have square brackets. Arrays are containers.
Okay.
Hopefully that helps out a little bit. That's how I think about it. It's like, oh, shipping containers, they look like, I don't know, whatever. That's Kyle logic. It's not very good.
Makes sense.
All right. Right, thank you. How/why does it say who let Toby out before listing Toby? Remember, we go in our algorithms sequentially. So we go from the top down. We're going to start on line 8 because it's our first line of code, create the array, come into the for loop. We're going to, I'm sorry. When we did that, we had the console log down here. My dog's down here. We're going to go into the for loop. We're going to check if it's Toby. It's not Toby because the first one's Bella. Come down to the console log, print out Bella. That's what we did. We'll loop back to the top. Not Toby again, it's Stark. Come down to line 13. Now it's Stark. Go back up to the top one last time. Is it Toby? It's Toby. So we're going to say who let Toby out, come out of the if statement, and then print it out and get Toby. That is how we got our output. Remember, sequentially, sequentially, sequentially. So that's what's going on here. All righty. Any last questions? Yes.
Yeah. My code is like identical to yours, I think. Except it doesn't print out the array. It just prints out who let Toby out. I'm not sure why. Must be missing something.
Most likely you're missing a console log outside of the if statement.
Okay.
For my dog's bracket, square bracket, I close square bracket.
Yeah, that's exactly what's going on. Thank you.
Absolutely. All right, everybody. We are going to move on if there's no other final questions. All right. Take a sip of coffee. Let's dive a little bit deeper here. All right. Looks like we're doing a lot of things. Like we just saw, we did one example here. I'm going to bring that back. We did an action here. We asked the user, what is your dog's name? We asked for that dog's name from the user. That is something we did, AKA a task. We also did another example. My dog's Bella, Toby, Stark. We went through there and we were trying to look for Toby. We were checking for Toby. We did 2 tasks here. We go over to our code. We have this code in here that's doing 2 separate tasks. Again, we ask that user for the dog's name and we have something that's looping through. But these tasks aren't necessarily the same thing. Additionally, we kind of have a dilemma that we haven't really talked about here. What if we wanted to add more tasks to this program? What if our boss came in or somebody wanted us to develop an application and asked us to do a lot more tasks? Not only do they want to ask for a dog's name, they want to ask for 5 more dogs' names. They want to do different things to the to the dogs' names. So we could have a lot of different things we could do with these dogs' names. We're going to be running a dog daycare, I guess, apparently. So what if we wanted to add a lot of tasks? What if we wanted to do those tasks again? Again, like I said, maybe we want to ask for 5 dogs' names instead. That's a lot of repetition. What I'm getting at here is that as our applications get more and more complex, we're going to have more tasks included in our applications. And as you all know, since you're almost done with assignment 1, there's a lot of things we could do with that. So our code base is going to get pretty large pretty fast in these more complex applications. Unfortunately, we can't just go through life anymore, just asking for a dog's name and printing it out. We are going to start building some cool stuff. And therefore, we need something to compartmentalize our code, to separate our code by task. And we need something that's reusable. This is because yours truly, as well as a lot of other developers, are very lazy. We don't want to have to type the same line of code a million times. We want something that's reusable. Also save the environment. We're going to recycle. So why we need something to help us out here, and who we call in to help is functions. Functions is a way that we use to separate our tasks from each other. Additionally, they also let us help repeat our code in a safe way. So we're going to be utilizing functions from here on out to help separate our tasks in a meaningful way. One thing we need to talk about for functions is this is a little bit different. Functions are created and called, but created and called are 2 separate things we need to do. So we really need to focus on if we're creating it or we're calling it. So in this case, we're going to start with creating a function. I'll get to that in a second. So we're going to look at creating a function. So let's go ahead and do that. We're going to explore that. We're going to bring in that code about asking the dog's name. And we're going to transform this task, this task that we just have floating out here in our code base, into a function. By magic, not really. We're going to do it together. And of course, go figure, to start creating a function, you use the keyword function, right? Isn't that difficult? Mind blown, right? Function is the word we start to create one of these things. The second thing is up to you as the developer. Your creativity comes in. The function name. You need to name your function so you can call to it. Right now we're creating it. Finally, at the very end, we use those parentheses. This is where we use parentheses. Think of it as, right now, think of it as the function's mouth, if you will. I'll get to why I said that in a little bit. But we're gonna have those parentheses there, which dictates it's a function. And then as always, we use curly brackets to include things inside of our function. Remember, what happens in these curly brackets stays in these curly brackets. It's Vegas style. So remember that, just like for loops, just like if statements, what happens in the curly brackets stay in the curly brackets. I want to really express that. So let's go ahead and start building this function off of the code we see above. First, we're going to take in that dog's name. We're going to define that dog name variable there. Second, we're going to drag in that dog name equals asktheuser.question. Now, take one close look at something. I didn't make a mistake. We didn't include that require there. This require, this asktheuser package for readline sync is a global variable. I might want multiple functions to access this. So I don't want to include it directly in my function. Do not include your requires inside of your functions. In case anyone didn't hear that, do not include your requires inside of your functions. These belong at the top of your code. So, will there ever be an exception? No, never, ever. I sound like a disappointed dad right now. No one's even disappointed me, but please don't, please. Okay, anyway, so we have that understanding. We've built this code. There's one more piece I want to go over with you. That is, functions are a lot like dogs. Go figure, making a dog, what is that called? Analogy right now. I almost forgot the word analogy. Dogs do 3 beautiful things. They eat stuff in their mouth, parentheses, like a mouth. They do something crazy. Look at our code inside of the function. It's doing something crazy. It's asking your user for a dog name. And then finally, unlike all pets, or unfortunately like all pets, it poops something out. In this case, it returns something. Functions return something back to us. So we use the keyword return. Now this was a lot. Functions have a lot of things to them. So we're going to take a little bit closer look at what we just actually did here for this function. Let's zoom it up. So what we started with was that function keyword there. To begin creating a function with a name, we start with this function keyword. Next, we have the function name. This is how we're going to call to it in the future. Remember, we're creating a function right now, not calling them. We need to have something very specific here, and it has to be unique. You'll also see that it's camel cased. I said ask with a lowercase a, for with a capital F, and etc. This is how you're going to write your functions. And then next, we have those parentheses, the mouth of the function, the mouth of your dog. Then the function does something crazy. That's contained within these curly brackets. Remember, your dog, your function is going to do something crazy within these curly brackets. And what happens in these curly brackets stays in these curly brackets. Then finally, your dog is going to poop something out. It's going to return something. Therefore, we use the keyword return. Now you might be asking so we'll send something back after the function finishes. Remember, it still goes sequentially, so your return should be at the very bottom. If you put your return at the top, return is an extremely powerful keyword. Return means get out of here. I'm absolutely done with you. No exception. Once your computer hits this return, it will exit the function and will take anything with it that is in front of return. Which leads me to another big point. You can only return one thing. You can only return one thing. You can't just slap a comma on here, put thing 2, and return it. You're going to get an error. So let's go ahead and take a look at this actually in the real world. We're going to come in here to Replit, and we're going to transform this code above into that function. So we're going to say function, and as we see, it lights up blue because it's a very powerful keyword. And we're going to say ask the user, oh gosh, what do I call it? Ask for the dog's name. Ask for the dog's name. Put that mouth on there and put those curly brackets there because we need it to do something crazy. Like I said, I'm going to take the code from above. So I'm just going to copy this. I'm going to take out this reassignment to Toby because it doesn't do anything. Well, it does technically on that line, but we don't use it for anything. So we're just going to put that. Technically, if you're also thinking to yourself, why do you have start here even though you're going to reassign it anyway? It's really just for demonstration purposes. We can take that out and do nothing. It still does the same exact thing. We can also make it into one line too if you wanted to, but I like to keep it just 2 lines. So we do that, and then finally, who knows that final word? Mouth it out to me. What is it? That's right. I can read lips. And I saw you all say it. Return. It is return. And we're going to return our string, in this case, dog name. Now, I'm going to comment down the stuff down here. And what I'm also going to do is I'm going to put a console log up here. Just to show you the magic here, I'm going to say dog name. And I'm going to run this program that we've just written. And I want you to notice something. The program's done running. It didn't do any of the code I put in that function. Did nothing. This is coming down to the thing that we talked about when we first introduced functions. You create them and you call them. You have only created the function. You have not called it. It will only execute after you've called it, not created it. Hence why we can compartmentalize using functions and putting this code in a safe haven until we actually need to use it. That is the power of functions. So I'm gonna just turn off, or I'm gonna let you guys talk. If anyone has a question real quick, we can talk about it very briefly. Anybody have a question about creating functions and what we've done so far? Go ahead.
Didn't it say in one of the beginning chapters, I just went through a bunch of them, and isn't return and console log, aren't those kind of the same thing?
Not at all. No. Remember, console log is for human output to see something on the screen. Return is an extremely powerful tool that gets us out of our function and returns something. If I'm a computer and I see return, I'm jumping out of that function. If I see console log, I'm going to push whatever's in those console log mouth or those parentheses out to the screen. So unfortunately, no, they are not similar on many spectrums. Yes, Mark, yep.
In your experience, how often do people make functions that have no parameters, such as this one you just made?
It will be a common case. What we're learning, you'll see less and less of that because maybe I wanted to make function that calls to other function, and maybe those functions take in parameters. It can be those kinds of cases. But yeah, there's absolutely, I'm going to say there's no true notice between if it does have parameters and no parameters. It's kind of almost 50-50 sometimes. Absolutely. Great question. All right, Kiki, do you have ask the user defined? Will it still create a question? That is actually a very good call out. It is not. It would actually give us an error on this one because we don't have it defined at all. Luckily, this code was not executed, therefore not checked. So it didn't give us that error. It would have given us a runtime error saying ask the user is not defined. So very, very good call out. I needed to uncomment that line 1 out. All right, Mark, why would you get an error saying a function is not a function? Make sure that you're using those parentheses. The program only knows it's a function if you're using parentheses. Otherwise, it's going to look for a variable. Hence why that's how it makes those determinations. Does the indentation matter for the function, or is that just an organization? Okay, Ryan, that's a great question. This is convention. It is not required. It does not matter about the tabs. You can put this over here. I do not recommend it. As our applications get more and more complex, if it goes within curly brackets, you should put a tab there to indicate it's within brackets. This will save you a lot of headache. Very good question. Jackson, might be thinking of methods and functions. Methods and functions, the word method and function in our context are absolutely synonymous. They are the same thing. Methods, though, are typically a Java concept, but methods can also be used interchangeably for the word function. In JavaScript, I will be calling functions functions. When we move on to the Java section, I will be referring to functions as methods. This is because some very picky nerd somewhere made this convention, and therefore I have to remember it. So yes, that is why the two words exist, but they are the same thing. Can you show us how to call the function? John, we'll get to that. Absolutely. Andrew, what exactly does return do specifically? Does dog name become unusable after the function is called? To your second question, it absolutely does become unusable because remember, dog name is within these curly brackets. Therefore, when this function is done executing, it will no longer be there. Well, I'll show you though here soon, show you the power of return when we're calling these methods. That being said, I need to move forward. So keep typing those questions out. If we have time at the end, we'll absolutely do that. Let's move to what everybody wants to do, and that is calling some functions. Let's take a look at that. So we have that. We're going to call to our functions. Remember, you create your functions and you call your functions. So we did a creative thing on our last thing. We gave our function a name. That name is very important because that is how we call to our function. If I name a dog and I want that dog to specifically come running to me, I call to the dog's name, aka start. If I want a function to start running, I call to it using its name. So let's look specifically how to do that. It's right here, clear and simple. Well, I say that with a caveat. This is new to us. So what you do is the function's name and say ask for the dog's name, exactly how it's spelt. It's very case sensitive. And then put those parentheses at the end. This parentheses is how the compiler can tell between a function and a variable. If I did not put these parentheses here, it will assume ask for the dog's name as a variable. And in addition, will give me an error saying ask for the dog's name is not defined. Make sure, if you are calling to a function, you put those parentheses there. Additionally, the function will not run unless you call to it. We've been over that, but I do want to really affirm that. You create a function, and it won't run until you call to it. How we call to it is how we see here on this screen. Let's go ahead and take a look at that. Coming down here, we're going to see the power of calling it. We're going to say ask for the dog's name. There we go. That's it. Come on, mouse. Come back. Okay. Mark, that's more of an offline question. We can talk about that later. I can't do specific questions during lecture. We can definitely take a look at it if we have time at the end. All right, ask for the dog's name. So I call to the function, and now we're running it. I'm going to show you that again. I'm going to comment this out and stop my function here, rerun it, and nothing happens. I uncomment out, ask for the dog's name, and I run that. What is the dog's name? And I type it in. I'm going to say Bella. It's going to print out Bella twice. Once because we have a console log, and once because the last, it's just, again, that weird replit thing, that this thing is the last thing it does, so it prints out whatever the value is. We'll talk about that later. So that is the power of calling the function. Now it's actually doing that code. Let's do one more thing. I'm going to take out this console log here. We need to see what return is actually doing. Return, we need to return the dog's name. In order to do that, well, I mean, we can return anything, but if there's nothing down here to catch it, it's basically useless. So if a function returns something, we need something to remember it. We know if we need to remember data, what do? We create a variable. Therefore, I'm going to create a let variable just because I want to use let. There's no specific reason. I'm going to say my dog's name. Take a close look that my dog's name and dog name up here in the function are not spelled the same. It's just because you can call it whatever you want down here. The value is just being passed through. And we're going to run this. What is the dog's name? Bella. Well, it's not going to do anything because I captured that and didn't console log it. Kyle, where'd you console log in? My dog's name. Perfect. There we go. Let's try to rerun that. Now we say Bella. There we go. And it outputs Bella here. So that is why we use return, because we return the dog's name. What if we didn't put return? Because return is optional. If we don't have to put a return down here, it doesn't return anything. So let's take a look at that. If I run this and I say Bella again, it returns an undefined, which means nothing. It's a vat of nothingness. So therefore, nothing. Therefore, we need to use return to actually provide a value back from that function. All right, what is the dog's name? Bella. We do it again. There we go. Bella is showing. All right. So I will take a few questions here, but we got to stay on time. So allow, and anybody here have a question about this?
I need to be excused for a second, Kyle. My battery's about to die, so I'm sorry.
You're completely fine. You don't need to let me know. But all right, good luck. All right, anybody else?
Okay, so probably explain this again, but I'm gonna ask one more time. Why is start? Because you inputted Bella, that's why start didn't pop up when you hit run, correct?
Correct. Remember, we go sequentially. Stark was on line 8, but the second I inputted Bella, it reassigned it.
Okay.
Hence, we return Bella.
Okay.
So like,
All right.
I assume it's just because they're two different variables, but like you have let dog name, you know, and that's the ask user and all that. And then you have let my dog's name equal ask for the dog's name. It just seems, I am assuming it's necessary, but just there seems like a lot of different variables for the same thing.
It is a lot of different variables, and I'm showing you they don't have to be named the same. If I wanted this to be dog name, technically I can call it dog name. I'm showing you that it does not matter in the context of here and here, that the variable names matter. So if we run this, we will still get Bella back. So just remember in the context. Yep.
Is that because return kicked everything out above it? That's why we can reassign it down at the bottom?
Exactly. Remember, what happens in these brackets stays in these brackets. And once you're out of those brackets, it forgets about it.
So if let's say your dog name was Const, and you put Bella in there, would it output that Bella is undefined?
If we do const here, we are not going to be able to reassign dog name. So this would actually cause us an issue.
So
we
try
said
put Bella, yeah. Okay, that's what I was expecting.
Yep, we can't do that because we cannot reassign a const variable on line 9. All right, if we have time at the end, everybody, we will. Yeah. Oh, okay.
Sorry,
Take one more.
I apologize. Quick question for you. So in the function, if we have multiple questions, so in this case here, we have asked the user that question, and we can actually put on the next line like something different, like uh, ask the age or something like that, dot question, and then put the question in there. As long as we have only one return, it doesn't matter how many questions, as long as there's one return, it should return those answers, correct?
Correct.
Okay.
It will only return whatever's in dog name at this scenario. You can ask it a million times, but the only thing coming out of that function is that dog name.
Gotcha. Okay.
One more thing I'll show you guys before we move on. There we go. Is that we can also, again, we want to show the reusability of that function. So I can ask for 2 dogs' names. So I'm going to say dog name 2, and I'm going to console log both. Let's look at this. We're going to run that. Come on. Help me out here. Oh, yeah. Wait. So I can let 2 there. Stop that. Oh, of course. All right. Give me a second. Rebel's being fun. Yeah, so much reload. There we go. Come on there. All right, rerun that. So what we just did is we put those 2 functions on line 13 and 14, reusability. So we're the first one to say Bella, and then it's gonna ask me again, Stark. Now we see Bella and Stark, right? This is the reusability aspect of the function. We can reuse this function, ask the same question, and get those responses back, right? I'm seeing some people's like, wow, right? That's a true mind blower. We can now reuse our code. We can save the environment. We can recycle. It's amazing. And also it takes less lines of code to do stuff. All right, let's go a little bit more into here too. I do want to go through exactly what the computer is thinking. We're going to bring in that code that we just wrote. Here we go. We have that function ask for the dog's name, and then at the very bottom, we ask for the dog and we print it out. As always, our program starts at the very top. Sequentially, sequentially, sequentially. We start at the very top. It's going to bring in read line sync. We go to function, ask for the dog's name. We create the function, but it remembers it. It does not run it, and it moves down here. Here, we're going to say, ask for the dog's name. You just called to the function. So in that case, it's going to say, okay, you called to that function. Let me go up there. Goes to the function, and it's going to run it now because it was actually called. So it goes in here. It assigns dog name to Stark. Again, it's just useless information because we're going to come down here and ask for a new dog name. We're going to say Bella, and then return is going to return. Oh, sorry, I said Stark in this example. It's going to return Stark because I said Stark in that question. So it's going to return Stark. So it comes down here, and my dog name now will be set to Stark. So when we come down to console log, that's why we print out Stark. And that is the magic of what the computer is thinking. All right, I know this is a lot. So everyone just deep breaths, deep breaths. It's okay, everything's fine. We're all doing great, we're still here. All right, and for an added bonus real quick, come back for a second, talk to me. I just want to know if you guys know these facts. I had to do Trivia Net the other day, and I got all these wrong. A peanut is not actually a nut. It is a what? Who can tell me what a peanut is?
Legume. Fruit.
None of them. It is technically a seed.
Seed.
It's a
I was close.
seed, right? Okay, I was like, what the heck? I thought it was like a fruit too. I heard that once. Mars may not be the largest planet in the solar system, but has the largest what?
Moon?
What is it?
Moon? I said
Moon?
moon. I don't know.
Desert.
I just
Actually has the largest mountain,
Mountain.
Mount Olympus.
Let's start it with an
Called
M, so
Mount
I'm close
Olympus.
again.
Mount
It
Olympus.
is 5 times the size of Everest. Yes.
Jesus.
Right.
Mm. Dang.
The tiny pocket found in jeans were originally designed to hold what?
Dime.
Pocket watch.
A rubber.
Screws. Pocket watch.
It was a
Pocket
pocket
watches.
watch. I heard it. Very good. Awesome, awesome. All right. Very good, everybody. All right. So we're going to keep moving on here. Oh, what did I just do? Everyone just left. It's also a seed. Ah, all right. This is a function. Okay, so don't worry. I didn't forget about this. We're going to check for Toby also. Let's go ahead and build a function with this one. As always, how do we start creating a function? We use that keyword function. We need to also create the name of the function, which is left up to our creativity. I'm going to call it check for Toby. And then I'm going to put a parentheses here. And then bear with me. I hope we stay friends. But what we're going to do is we're going to put in our ARR, which stands the shortness of array of dogs. And then we're going to close it and include that code in there. Now, array of dogs, ARR of dogs, what is that exactly? We call that a parameter. A parameter. Information that is being passed in to the function. Remember, you can feed dogs. You can feed functions information. And then they do something crazy within that function and then return something. Return, of course, being optional. We can return nothing. But one thing I want to talk about this code here is that it says mydogs.length. We are no longer using mydogs.length. We're passing in this array, this information. So instead, and I also know that mydogs.length is not within these curly brackets. So what we're going to utilize is actually the parameter. So what we do is we say ARR of dogs dot length here, and then increment that. What we just did here is that now we're utilizing that parameter to bring it into this function and use it in our for loop. Again, you might be asking yourself, do we need to include a return here? Remember, return is optional. Optional, optional, optional. We're just checking for Toby, and we're console logging Toby who let you out if Toby is found. So actually, this return is not really necessary. It returns nothing, so therefore it's just gonna be undefined, so we can get rid of that if we want. Let's quickly take a look at this. We're going to now convert this code down here. I'm gonna comment out this stuff up here. Oh, mouse. There we go. All right, let's take this code down here, and we're gonna, I'm gonna keep it commented out actually. We're gonna create our function. Function. And I said, check for Toby. Very good. And then inside of these parentheses, I'm gonna put the name of my parameter. Basically think of it as a gateway now I can pass information in as. So I say ARR of dogs. And then those curly brackets to contain all of my code within my function. So inside of this function, I'm going to place this for loop now. So I'm going to copy the for loop. I'm going to paste it here. As you see, I'm putting these tabs here. This is my OCD. I'm making it more indented just because I can read it better. It is not necessary for the actual code. All right, and I'm going to take out this console log here. So this is it. And one last thing we need to do is take this parameter, array of dogs, and we're going to replace my dogs here. Again, we want to use the parameter. You might be asking yourself, can we just use my dogs since it's up here and it's a global parameter anywhere, it's a global variable anyway? Technically you can, but in this example, we don't want to do that. We want to actually practice our parameters. So we're going to pass in this parameter instead to the function. So my dogs equals Bella, Stark, Toby. We created our function. Let's go ahead and actually run this. So what I'm going to do is going to take my dogs, I'm going to bring it down here. And I'm going to say check for Toby in here. And I'm going to say my dogs. There we go. And now let's go ahead and run this. And it's going to say who let Toby out. This is because we called to check for Toby, which is my dogs, and Toby is within that array. So we just passed that array of material into our function. Now, I know this is a lot of information and a lot of things being thrown at you. So one last thing, and I'm gonna look at this. Would you have to define array of dogs? Michael, to your question, no, you do not have to redefine array of dogs because it's being technically defined here. And if you're also asking, yes, you can technically redefine a parameter, but I would not recommend. Array of dogs is already being defined, so we don't have to redefine it. And the if array of dogs. Oh, that's actually, yeah, very good. As you can see, my dogs also works. So yes, array of dogs should be down there too. Thank you. It's absolutely a typo. So yeah, array of dogs, we replaced that as well. So now we're fully using this parameter. Let's rerun it just to make sure that it still works. There we go. Who let Toby out? Let's go ahead and take Toby out of here. Just to make sure. Poor old Toby. We run that, and now we don't get who let Toby out. How does array of dogs know its length? Remember, array of dogs is just a parameter. It is a container. It's a vessel passing information. It knows its length because, and I'll put Toby back here. When I pass my dogs in here, it's going to come back over here. It's going to come up to the function and pass an array of dogs. So array of dogs is going to turn in to whatever the value of my dogs is. That's why here, now it can check what was the value that was passed into array of dogs down there on line 39? Well, it was my dogs, which is an array of 3. Now, I know this is, again, a little bit, so let's go ahead and go through what the computer is actually thinking for this one. We're going to start here with check for Toby and this code. Again, we're going to build this function. It's not going to do anything because we didn't ask to run it, so it's just going to build it. It's going to create it. And we're going to come down here to my dogs, Bella, Stark, and Toby. It's going to create that array, come down here to check for Toby. Now, this is where the magic happens. It says like, okay, you wanted to call to check for Toby, but you want me to bring along my dogs. So what it does is it goes up to the function and it brings my dog with it. It brings my dogs with it. An array of dogs, its value turns in to that array of Bella, Stark, and Toby. That's information. This value is being passed into that parameter. It's, again, traveling up there. Think of it as a vessel. It's going up into that function. So array of dogs is there. We'll get to those. So this is how it's actually working. After that, it's going to go into this for loop and, of course, just loop over that a few times in order to find Toby. When it finally finds Toby, it will print it out. When it's done with the for loop, well, it sees no more code to do, so it exits. So that is how the computer thinks, but also a lot of information being thrown at all of you all at once. So I'm going to unleash the beast here at 6:30. So we're going to just answer a few questions. So go ahead and ask away. I'm going to actually go up here. I saw a few questions. So replace the okay, the if statement. Andrew, how does array of dogs know its length? Because again, it's passing it through the parameter up there. What was the usage of array of dogs to abstract the code? Was the usage of array of dogs to abstract the code? Technically, yeah, it's making it abstract. Now I can pass in anything I want to into those parameters, and I can change it to whatever I want. So if I want to just pass in another array here, we'll say Kyle and maybe Sarah, and just run that. It'll only print out one time, but then I include Toby in here. There we go. Now we're going to get 2 because we just ran that function twice with 2 different arrays, and Toby's in both of them. So we're going to have 2 outputs. So what we did was we abstracted that parameter, I guess, I'd say make it more general so we can reuse that parameter. Remember, functions are all about reusability. So array of dogs is just a placeholder. You can think of it as a placeholder. It is that vessel that we use to transport information up there, and that's what we're referring it to it as. That's what that variable is. How does it know what should be an array of dogs without it being declared? You do variables. We declared that variable down here. My dogs, it's being passed in there. So it knows what it's supposed to be because we passed in the variable here, which transfers up here to array of dogs. Array of dogs is technically defined. We don't have to put a let in front of here. Do not put a let in front of your parameters. Think of it as a nice giving of JavaScript where you don't have to put your let in front of here to define it. It's already come predefined. Another thing is too, we can add multiple parameters. We can only return one thing, but we can have multiple parameters. Param2, something like that. And console log our param2. Now remember, this is only our first round with functions. We're gonna see a lot of this again. So don't feel like you have to remember all of this tonight per se, but this is a good way to get our feet very wet with functions. So param2, we're gonna just include, hello. I'm gonna run that example right there. Perfect. So now we see who let Toby out, hello, because that's our second parameter, and then who let Toby out from our second function being ran there on line 41.
Kyle?
Yes, Melanie.
With what you just put out on 39, 40, and 41, can you tell me, can you like correlate it to the output?
Excuse me, yep. So what it's gonna do is it creates that array, comes down here to check for Toby. It's gonna pass my dogs and hello. So what it does, it comes up here to line 30. Array of dogs is gonna now be Bella, Stark, and Toby, because that value got passed up there. Our param2 is gonna be hello, because we passed hello up for param2. As you can see, they're both separated by commas. So now we start going into the function. For loop, we're gonna iterate 3 times. Why? Because my dogs is array of 3. So we loop over it. Toby's not the first one. Toby's not the second one. Toby is the third one. So it console logs who let Toby out. That's our first output. Who let Toby out? When it gets to 3, that's it. That's all that's on that array. So it comes down to line 36. Console log param2, which is, again, param2 is hello, because we put hello down here. So it console logs hello. Then we go to 41. It's going to do the same thing. It passes in this array. We didn't give it a second parameter. It's not always required to put in your parameters if it isn't going to hurt your function. So that one's a little dangerous. I would say always include your parameters. So I'm just going to, well, we're explaining this stuff right now. It's going to pass Kyle, Sarah, and Toby, that array up here to array of dogs. It's going to loop through that, and it's going to find Toby once. Therefore, it's going to say who let Toby out.
What if you want to look for
hopefully that helps. I'm sorry?
What if you want to look for Stark?
If you want to loop for Stark, then we would have to change this here to Stark.
Kyle?
Melanie, yes.
So because you put the param2 in the function as a second parameter, if you put on line 41, if you did after the array comma hello, it would do it like automatically. It automatically hello goes to parameter 2, so it would do it again.
Oh, here I gotta change this back to Toby. There you go. We said hello with no exclamation points there, but hello with 4 exclamation points here. Hence why we see this. That param2 became dynamic. We can print out anything now.
I got a quick question. Why did you put const my dog at on line 39 versus at the top? Does it matter where we put it at?
Well, if we put it down here, what's going to happen? Sequentially, my dogs is being called on 40, but the variable it wants is on line 42.
Yeah,
that means on line 40, it's not going to exist. Sequentially. So it does matter where you put my dogs, but if I put it up here, that's completely fine too. If I put it at the very top, as long as it's above where I use it. Otherwise, the computer won't know what's going on. So one last thing I'm going to show you here is array of dogs. What if someone said, what if we want to search for Stark? Well, we switch this out for Stark then. But what if we wanted to make it more dynamic? What if we rename param2 to search for dog? This no longer will be necessary on line 36 because param2 doesn't exist. And now we can come in here and replace Stark with search for dog. We're utilizing that parameter now within our conditional. So check for Toby. We're going to say, okay, look for Toby now in my dogs. And even better, I'm going to say search for dog in my string here. Now we're getting a little complex, and I'm gonna shrink that so people can see. So let's go ahead and run this. Who let Toby out? All right, we've seen that before. How about Stark now? Let's go and run that. Who let Stark out? So we can utilize these parameters to make things more dynamic and search for whatever we want and increase reusability.
That one got me. Yeah, I don't know.
I know. And that was the last thing I wanted to show you all. This is a little bit more tricky because we just got into functions. But yes, we can pass in as many parameters as we want here and utilize them within here.
So, for example, yeah, may I ask one question? So in line 32, you say if array of dogs, brackets I equals. Can you put search for dogs and then array of dogs in there, or no?
I heard search for dogs, and then you said array for dogs. Where would you want to put array of dogs?
Comma, in the array of dogs.
Here?
Yeah.
Remember, we can never use commas within conditionals. The only way you can chain conditionals is with the ampersands or our pipe cleaners. Ampersand standing for and pipe cleaners standing for ors. Commas here will not mean anything to the computer. In fact, it will give us an error. Well, unfortunately, it didn't give us an error, but it's not going to do anything because JavaScript is way too forgiving. But essentially, this doesn't do anything. What you're going to need to do is do ampersands array for dogs equals Stark if you want to chain your conditionals. So I'm going to go through the questions here, and I'm just seeing some faces. And don't worry, a lot more questions will be answered next class. Well, hopefully. Let's see. Variables, arguments, and parameters. That's a great question. What is the difference between arguments and parameters? An argument is what we are passing in here. These are our arguments, essentially what we're passing in. And then our parameters, I always get these mixed up too. I might be mixing them up. Our parameters are the ones included in the function. So that's what we keep those two differentiated. That is the terminology.
So arguments never go inside of a function. It's always the parameters.
Essentially, it's just terminology. Unless you're correcting me, I didn't quite get that one.
No, so what I'm asking is, does it, arguments would not go inside of functions, technically, right? You would go only if you're checking for something, right?
Arguments are what goes into the mouth of the function, what goes into those parentheses.
Okay.
If we look at what we just did here, my dogs is the argument. Well, array of dogs is the parameter.
Yeah.
Argument gets passed to the parameter. That value gets passed to the parameter.
Okay, makes sense now. All right, I see.
All right. This last example, again, is a little bit more beyond what we were going to cover today, but I did want to show you just the power of multiple parameters. So don't let this get stuck on there. Still explore functions. They're powerful. Remember, we create them and then we call them. They're used to oh my gosh. Something.
Compartmentalize.
Wow, I cannot say it today. That word.
Compartmentally.
Compartmentally. Yeah, compartmentulate our tasks, and then also for that reusability. All right. So unfortunately, we are getting after time. So I'm gonna let you guys go to your groups. Thank you very much for working through this with me. We're gonna meet back up here at 8 o'clock if you wanna go more into functions, and I'll have more time then to also answer questions. So feel free to join us then. And then, yeah, great for lasting through. I'm sorry about round one. It is always it is a bit of a beast when we come to functions. So, but they are really powerful, and we'll get to know them quite well. So have a great breakout, everybody, and I will see you back here at 8. Bye, everyone.